Okay, we're going to take a look at a Pulleys question from an Edexcel past exam paper. When you are doing Pulleys, or any really force question, you want to start by labeling all the forces in your diagram. So I have particle A, I'm going to add in weight first. So the mass of particle A is 3m, weight is 3mg. Particle B, the mass is m, weight is mg. Now there's a string here. We're going to be resolving forces from the point of view of the particles. So the string is pulling the particle A up towards the pulley. The tension goes in this direction. Particle B, similar, being pulled upwards. There is a reaction force, particle A, from the slope. And, okay, these are all the basic forces that are there every time. I'm not going to actually read the question and see if there's anything else. Small stone mass 3m, stone mass m, initially A held at rest, fixed rough plane. Okay, so rough plane, we know it's going to be friction. The direction friction acts in, we know, is always going to be opposite to the direction of motion. So I need to actually read through the rest of the question to see which way A is going to move. It could be either way. I see stone A released from rest, begins to move down the plane. So super important. It's moving down the plane. The friction is actually going to be going back up the plane. Friction. Reading through the rest of the question, there is nothing else, I don't think. So there's angle alpha, pulley, particle B, coefficient of 1/6. The coefficient of friction between A and the plane is 1/6, so mu equals 1/6. I can use that later. All this modeled. And then, yeah, that's all the forces. In these questions, whatever part A is, whatever part B is, whatever it asks you to do, you're always going to resolve your forces for both particles. So for particle A, there's going to be two directions. And if particle B, there's just one direction, we'll get three equations. And we actually read the question, it does say, part A, write down an equation of motion for A, which is want you to do F equals ma, so resolving your forces. I'm going to write down A, but I'd be doing this anyway, first step. Okay. When you're resolving on particle A, though, A is on a slope. A is moving down the slope. When you're on a slope and it's sort of, it's not horizontal, not vertical, all your forces in the question want to be either parallel to the plane or perpendicular to the plane. Friction is fine, friction is parallel. Reaction is perpendicular. The weight is a problem, because weight is neither. Weight is straight down. So you're going to need to split this up into its component forces. One component in the direction perpendicular, and one direction in the component parallel. Okay, this alpha here is always going to be this one. So this force here is adjacent, so it's going to be 3mg cos alpha. This is going to be 3mg sine alpha. I like to just redraw when it gets to this stage, just because there's quite a lot going on with particle A, so it can just be helpful. Here's particle A, right? So my force is down, because it's quite easy to forget about, this little one in red, the 3mg sine alpha, because you've added it on. But that is there. Don't forget about that. 3mg sine alpha going down the plane. Friction. That was weird. Friction and also tension going up the plane. Reaction there. And the 3mg cos alpha. My initial 3mg has not been forgotten about, right? It's just been split up into these two smaller forces. So that's all the force in particle A. I'm now ready to resolve. So let's first resolve in the direction parallel. Because it's moving down the slope, you're always going to want to resolve in the direction of motion. In this case, that is downwards. So it's going to be forces down minus forces up equals mass times acceleration. Forces down is 3mg sine alpha. Forces up is friction and also tension. And that's going to be equal to m. Well, the mass of particle A is actually 3m. A is unknown. We're solving for A, so it's just A. This is actually what I want for part A. That will do. So I'm going to put a B here, but just carry on. This does not affect what I'm doing. I always do resolve down the plane, or up, depending on movement. Then I resolve perpendicular. In this case, there is no acceleration, so the direction doesn't really matter. I'll go up or out of the plane, so I have forces out R minus forces in, so I'm looking over here, is 3mg cos alpha. And yeah, acceleration is 0 in this direction, in this perpendicular direction. I'm then going to do, I've done particle A, before I try and solve anything, before I do any substitutions, do particle B as well. Okay, particle B is more simple, it's just moving vertically, so I'm not going to worry about doing it perpendicular and parallel. It's just moving upwards with the same acceleration, so T minus mg equals ma. In A-level mechanics, right, the tension is always going to be the same, both parts of the string. Acceleration is always going to be the same. We'll come back to that later, but you can just assume that. Okay, now I'm ready to solve all my equations. I'm going to label them equation 1, equation 2, equation 3. And before I start solving, just some helpful things to write down. First of all, friction. So the particle is moving, which means friction is maximal, right? It's the maximum amount of friction. And I know that that is going to be given by mu r. F equals mu r only when the particle is moving, or if it's in limiting equilibrium. In this case, we are moving, so we're fine. And mu is 1/6, which we wrote down earlier. So the friction is just 1/6 the reaction force. I also just have this triangle with alpha in it, so tan alpha is 3/4. That's just a little bit helpful. Opposite over adjacent, I can find the hypotenuse by Pythagoras theorem. I'm just writing my values of sine alpha and cos alpha. I don't need to do inverse tan at any stage. Okay, now I'm ready. 99% of the time, you're going to start with this equation 2 here, and you're going to sub that in straight away into, well, in this case, we're going to go into equation 1 once I replace friction with mu r. So I have 3mg, now sine alpha is 3/5, so I replace sine alpha with 3/5. 3 times 3/5 is 9/5, so 9/5 mg minus friction, which is 1/6 r, minus t equals 3ma. So I've just rewritten that there. I'm now going to write equation 3 underneath, which is t minus mg equals ma. These equations, if you've done it correctly, one of them will have negative t and one of them will have positive t. So the quickest way to go about it is to add them together and get those t's to cancel out. Eliminate t and solve for a. Even if the question is actually asking you to solve for t, you can just solve for a this way and then substitute back in. So we're going to add the equations. Okay, so 9/5 mg minus 1/6 r minus t and plus t will cancel out, so then it's just minus mg. Right hand side is 3ma plus ma gives me 4ma. And then I did say the second equation, you are going to want to substitute in here. So you usually just get a nice expression for r. In this case, it's 3mg cos alpha. Cos alpha is 4/5, so 3 times 4/5, 12/5. R equals 12/5 mg. I'm just going to put that straight in here. So 12/5 mg. So this equation, actually, the left side, everything is a multiple of mg. I have 9/5 minus 1/6 times 12/5 minus 1 mg. So if you have calculators, you type in your calculator 9/5 minus 1/6 times 12/5 minus 1. That's the left hand side. Right hand side is still 4ma. And what this is going to get you is going to get you 2/5 mg. So we get 2/5 mg equals 4ma. My m's will cancel off. You could have done that earlier, maybe, depending on when you're substituting for that r. And then I'm solving for a. So unknowns in these questions, always a and t. Sometimes students do worry about, well, m is unknown, so am I not solving for that? But 99% of the time, m is just an unknown constant throughout the whole question. And your final answer will either be in terms of m, or the m's will just cancel out like they have done here. So unless the question actually explicitly says, what is the value of m, or what is the mass of the particle, you do not need to treat m like an unknown, okay, like a variable like you're solving for. The two unknown variables are t and a. I've eliminated t, so now I solve for a. Divided both equations by 4, a equals, you're going to get the correct answer, because 2/5 divided by 4 is 1/10. So there we go. Done part A, done part B. Now we're on to part C. just very quickly, I could obviously go back in and solve for t. I could scroll up and go to either equation 1 or equation 3 here, and they both are just going to be able to give me that. Question doesn't ask for it though, so I'll leave it. Pulleys is a sketch of velocity time graph for the motion of B, starting from when A is released, and it's released from rest, and going on to the instant just before B hits the pulley. So going up, just look at the picture, particle B, it starts from rest, it moves up. And we did solve for A, right? We got A equals G over 10, which is 0.98. It's a constant number. So B is accelerating with, well, it's moving with a constant acceleration. You have to know what that looks like on a velocity time graph. Remember, velocity time graph, and you do need to know this, that the acceleration is represented by the gradient. So acceleration is a constant number, means our gradient is a constant number, which means actually it's just a straight line. And it's released from rest, which means the initial velocity, on the y-axis is velocity, x-axis is time. Initial velocity is 0, so it starts from 0, and then because acceleration is constant, it just goes in a straight line. It does say explaining your answer, so I've got 1 mark out of 2 so far. So you have to explain that the acceleration is constant. This means that the gradient is constant, which means I have a straight line. And then you could also write a sentence about how it starts from rest as well. The question was just looking for this explanation about the constant acceleration. Finally, part D, the string is not light. How does it affect the working? This is a standard answer. You just need to know these. If the string is light, this means that the tension in both sides or both parts of the string will be the same. So what this means is, we called both of these values T in the string of tension. If the string was not light, it would be T1 and T2. They wouldn't necessarily be the same. It'd be a lot harder to solve because they wouldn't cancel out here when I add my equations. The same thing actually comes from the fact that not just the string being light, but the pulley being smooth. So both of these assumptions, which every question will have these assumptions, both affect your answer in this way. So for part D, you would say the tension would no longer be the same in both parts of the string. The third thing that's always true is that the string is inextensible. It doesn't ask for it here, but just in case you ever do get asked, the inextensible string, that means that not the tension, but the acceleration is the same. The acceleration of both particles. Let's scroll up here. Acceleration of both particles is the same. So those are your 3 modelling assumptions in these questions, and then the effect it has on your working on your mathematics. I hope this is helpful. Like I said, it's always just the same. You resolve your forces. 2 directions to the particle on the slope, 1 direction particle off the slope. You add them together to eliminate tension. You can sub in for your reaction force to find the friction, and just go from there. Let me know any questions. Feel free in the comments. And other than that, I hope it's helpful.